You know what I love about light is that it comes in all different kinds of colors. And we normally break these colors down using something called a prism like this. It's like a piece of plastic in a triangular shape. Now you can do it other ways using a spectrometer. It also has a prism-like thing inside of it and a special detector which can detect the different frequencies of light that can be illustrated right here on the screen. So here we have a wavelength. Right here you have a lot of deep blue and you have a lot of red. And in fact, the human eye can only perceive wavelength about between here and about here-ish. That's it. The rest of it is invisible to us. This is kind of getting into UV and this is getting into infrared. Now this thing measures all the light that enters it through this little cap right here, through this fiber optic. So if I take it off, I get to see the room. And in fact, you notice something. You might see two peaks right here and right here. This peak is a little bit more on the green side, actually getting closer to the blue. And it's a little over 500, and then something kind of in the orangish side, a little over 600. And the neat thing is that I can tell that because, look, when I look around me, I definitely see kind of a yellowish light in here. So this actually picks that up. But you know what's also cool is it can figure out what the frequency of this is. This is a laser. See, it's got a nice green color to it. And it says it's 532 nanometers. Now, how true is that? Well, looky here. Oh my gosh. It is indeed 532 nanometers. You can see right there. It also has a peak that's a little bit above 800. Now that 800 peak comes from the fact that the original light to make this laser actually isn't green. It's this little bit of it's a very deep red near an infrared. And that light strikes something called a non-linear crystal. And that crystal will turn that red light into the green light here. That's very neat. It's one of the neat things that ways we discovered how to make light of different laser kinds. But you don't just have to look at lasers. You can look at something like flashlights. Now this flashlight looks very white, like this. And I shine it here and I notice that, yes, indeed, it is pretty white. There is something right here, which is kind of a lot of UVs. This is actually more of a close to UV spectrum. It's a very blue near UV. The rest of this is very white. And what that says is that this thing actually, if I could probably give myself a tan if I sat there long enough, because it does have a little bit of UV or near UV light coming off of it. So this thing can tell you all sorts of stuff that your eyes may not normally be able to tell you about, all the light that's going on around you. And if you show this at the sun, you'll see all sorts of stuff. You'll see the infrared, you'll see the UV, and you'll see everything in between. And you can use it to figure out what things are made of. You can use it to figure out what's going on in the chemistry or the physics. And that's what makes these things so powerful. They can tell you what's going on in plasmas. They can tell you the interactions. They can tell you the interactions chemistry. They can tell you what something is made of. It's fantastic. And the uses of these is incredible. It's just all over physics and chemistry. They're very important spectrometers, and interpreting spectrographic information is really important. So that's it about light. Take it easy. Have a wonderful day. Bye-bye.